Hi, the topic of today will be about the exponents. So, first of all, what we will do is that we will see some mathematical application, and then after that we'll define the power and exponent, which will be followed by properties of exponents, and then finally we'll do some examples to consolidate our new skills. In mathematics, we use the concept of exponent in a lot of domains. For example, for the matrices, we use the exponent in the product of matrices. For the function, we also use it for the composition. And then finally, for the sets, we use it for the Cartesian product. So now, I will show you in the next scene a more concrete example. But this is only for motivation. You don't have to memorize this and understand it well. So now, let's suppose that you work for a company and they ask you to create a model in order to be able to predict the salary based on the experience of work in terms of number of years. So they give you an Excel spreadsheet in which you have two columns, the salary and the experience. So here in the following plot, all these X represent some data from our different employees. So here what we did is that we checked the relationship. So Y is the salary, X is the experience. So this relationship doesn't seem to be strictly linear. However, we could try to use a linear model to see how well it goes. So here, beta 0 is the intercept, beta 1 is the slope. So here this is a linear relationship written as a straight line. So beta 0 and beta 1 are some real numbers. So if you draw this line on the plot, then you can see that it doesn't match on all the points that we have. So what you could wonder if there's any way to have a more flexible model. So the answer is yes. So we will use what we call polynomial regression. So the idea is to use a similar model, but we add more parameters to be able to fit some quadratic effect, cubic effect, etc. So basically, you're the one who is choosing how many of these effects you want. So here, the formula that you see on the right, you have beta 0, you have beta 1, beta 2, etc. until beta p. So you have a lot more parameters. So beta are the weights, and p is a number that you choose in the natural number, but you don't choose 0 or 1 because 0 corresponds to just a straight line, 1 corresponds to a linear model, and then for a higher value, you have a more flexible model. So as you can see on the plot on the left, now your prediction will be better and your curve is really more adapted to the plot on the left. So now let's define the exponents. So the power operation consists in multiplying an element A by itself multiple times. So the number of factors involved in this operation is called exponent of the element A. So let A be a real number. Then we have that A to the power of n is equal to A times A times A n times. So n is the exponent in this expression. So that's why it's in yellow. So there are a few ways to denote this. So we can say A raised to the nth power or A raised to the power of n. So in your life, you might have been lucky and have seen the exponent in multiple occasions. So let A be a real number. Then we have these particular cases. So A squared is equal to A times A. So as an example, you can see that for the area of a square of length A. Here, A to the cube, A times A times A. This corresponds to the volume of a cube with length A. And then here maybe you saw that A to the A, which is also written as A to the power of 1. And then finally, A to the power of 0 is equal to 1 if A is invertible. In some case, you might see some negative exponent. So if A is invertible, we note A to the minus 1 as the inverse. So if n is a natural number, then A to the power of n is also invertible, and we note A to the power of minus n as its inverse. So for example, if you have 2 to the minus 2, you can write it down as 1 over 2 to the square, which is equal to 1 on 4. So now let's look at the properties of exponent. So let a and b be some real number which are invertible, and m and n be natural number different than 0. So then we have the following rules. So if you have a to the power n plus m, this is equal to a to the power of n times a to the power of m, so the exponents are getting added. If you have a to the n minus m, it's equal to a to the power of n divided by a to the power of m. So it's a consequence of the first one. As a third rule, if you have a to the power of n and all this to the power of m, then you multiply the exponents, so it's a to the power of n times m. And finally, for the last one, if you have a multiplication a times b and all that is to the power of n, then you can distribute this n inside a parenthesis to the different elements of the multiplication. So it's getting equal to a to the power of n times b to the power of n. So now it's your turn to use this rule. So simplify the following expressions. So here you have 4 different expressions, and then your goal is to simplify them by using the rules that we just saw earlier. So pause the video and try to find the solutions. So if you found out the solutions, congratulations. They are respectively 2 to the power of 5, 7 to the power of 6, 81 on 8, and then 7 on 6. So if you are not able to do it, no problem, we'll see them in the next scene. Okay, so now let's solve these expressions. Let's simplify them. Okay, so for the first one, it's 2 to the power of 2 times 2 to the power of 3. So here, remember, the exponents are getting added together. So it's the first property that we saw. So it's 2 plus 3 equal 5. So it's 2 to the power of 5. For the second one, it's the third property. So it's 2 times 3. And then you get 7 to the power of 6. And then for the other one, you cannot simplify them directly. So you get 9 to the power of 2 divided by 2 to the power of 3. So it's 81 on 8. And for the last one, you get on the numerator 7 times 6 to the square. And then on the denominator 6 times 7 times 6 to the square. You have a common factor, so you can simplify it, and you have 7 and 6. So now let's go to the conclusion. So we saw a few different elements. So we defined the power and exponent first. Then after that, we decided to take a look at the properties of integer exponents. And then finally, we decided to do some example in which we had to simplify expression with the properties of the exponent. So the most important one is the last one. By doing it, you will be able to fully have a good understanding of the exponent and its property. Thanks.